Can we start our session? Right, guys? Let's see. I have given some home assignments for you, right? What was the home assignment from Excel study material? We have to discuss now. Which question? Which question? What were the home assignment for you? Question page number 17. Page number 17. Page number 17. Question number 53 to 58. Isn't it? Question number 53 to 58. 53 to 58. Let's look at the question. Can anybody give me this one? This material? Okay. Have you completed it? Anyone completed it? Have you done it? Navi? Can I see that? Where is that? This one. 53, 53. From here, 53, 54, 57, 8. Okay, good. What about you, Janardhan? You didn't do the last one. I remember that. Why was that? What happened the last time? You forgot it, and this time, what happened? Oh, that's not cool, man. That's not cool. What about you, Sarah? 53 is okay. 55 is okay. 56 is okay. What about you, like? 53 is just 53 and 53 and I don't know. Yeah. That's okay. You have that. I thought that. Okay. Okay. No one is online. Okay. Let's see. Let's try to do these questions. Try to do this question. I think you have these questions. Have you written the questions in it? Have you written the questions in your notebook? That's a better method, I think. You should write the questions in the notebook. That's a better method. Only with the questions you will be able to understand the answer. Right? You should write the question whenever you are trying to answer something. Question is very important. Writing this question is very important. You should write the question if you are going to answer something. I am not asking you to write the question in the class because we don't have that much time. That's why. If we get too much time, I will definitely ask you to write the question. So it's that important. It is that important. Okay? Then look at the 53 question. Question number 53. We have to make it fast. An object 4 centimeter in size. That means object size. Object size is 4 centimeter. Is that okay? And is placed 25 centimeter in front of a concave mirror. That's a concave mirror. In front of concave mirror, the object is placed. That is 25 centimeter in front of it. Isn't it? Is this the figure? Okay. And focal length is 15 centimeter. It is given that the focal length of this concave mirror is 15 centimeter. What will be the sign of this focal length? That is minus. You have to measure to the right. That means the sign will be minus. Siddharth, have you done this home assignment from 53 to 58 or 59? Okay. Have you done it? Okay. So f is equal to minus 15 centimeter. We got that. And the first question, look at the first question. At what distance from the mirror should a screen be placed? Should a screen be placed? At what distance from a mirror a screen should be placed? That is the question. And in order to obtain a sharp image, in order to obtain a sharp image, you need a sharp image. That means you need to find the image distance. You need to find the image distance. You have to find the image distance. What is that image distance? That is B. B is the image distance. You need to find it. That's the question. What are the data you have? What are the data you have? You have this one, U. What is the value of U in this case? U is always negative. U is always negative. Jonathan, Write the question and write down this answer. Okay. What is this? U is object distance. Object distance is always negative. That means it will be minus 25 centimeter, right? It will be minus 25 centimeter. And we have this U and F. Then you can find V with the mirror formula. What is the formula? Mirror formula. What is mirror formula? 1 by F is equal to 1 by V plus 1 by is mirror formula. Very simple one. 1 by what is F? Minus 15 is equal to 1 by V. That's we have to find. That's what we have to find. So 1 by V plus 1 by U. U is minus 25, right? Now you can find 1 by V. Just bring this 1 by minus 25 to the other side. What will happen to it? There is 1 by minus 15 already. If you are bringing this minus to the other side, it will become positive. It will become positive. Plus 1 by 25. 1 by 25 will be the answer. 1 by 25. Just cross multiply, you will get a correct answer. Just cross multiply, you will get an answer. How will be that? 1 by V is equal to cross multiplying it 25 plus minus 15, right? 25 plus minus 15 or 25 minus 15 divided by minus 15 into 25. Minus 15 into 25. 25 minus 15. What is that? 25 minus 15. That is 10 divided by minus 25 into 25. Minus 25 into 25. What is that? Minus 375. Isn't it? Minus 375. 15 into 25. Minus 375. It is 1 by V. Then 1 is V. Reciprocal of it. Take the reciprocal of it. Minus 375 divided by 10. How can you divide this 375 with the 10? Just take a place and put a decimal point there. Take a place, put a decimal point. That's all. Take a place 375. Write 375 first and take a decimal place, take a digit and put a decimal place there. That will be minus 37.5 will be our answer. That's B. Now you have to place you will get a clear image at this point, 37.5 in front of the mirror. Have you got that answer? Everyone got that answer? Is that answer correct for everybody? Good. What about you, Aaron? Aaron, you have got that answer correct. Have you done this?
No, I just joined. I didn't understand.
You should take a photo of that note and send that personally to me. Can you do that?
Last thing.
This home assignments.
Okay.
Okay. I will personally check that. This is our 53rd question. Okay. Now we will go on the next question. What is the next question number? 54. What is the next question number? There is a second question in it, right? There is a second question in it. What is that second question? Find the size of the image. What is the size of the image? HI is the size of the image. How can you find HI? You have an equation for magnification, that is HI divided by HO. From this equation, you will get HI. But the problem is that we don't have magnification. So you have to find the magnification first. How can you find the magnification? You have another equation for magnification. That is minus V by U. That is the equation for magnification, right? Then minus B. B is what? This one. Minus 37.5. You should not forget to put this minus sign. You should not forget to put this minus sign. Minus V. V is minus 37.5. So you have to write it like that. Okay. So divided by U. What is U? U is given in the question. U is given in the question as minus 25. So the term or the numerator will be positive. 37.5 divided by minus 25. What will be the answer? That's magnification. What will be the answer? What is the answer you are getting? 375 divided by 25. Do you know? Hi. With the constant values. Right? Welcome. Have you done the home assignment? That's the, oh, you don't have that, right? I will give you one. Is that okay? Then I'm going to type. We collect it from office. Okay. So what is this value? 37.5 divided by 25. What is the value? Minus? Minus? Is it 6? 15. 1.5. Minus 1.5 is the answer. Have you done it? Minus 1.5. Yeah, that will be it. Minus 1.5 will be the answer, right? 25 into 15. Is it wrong? What does it happen? What happened? Minus 1.1. Maybe this is HA maybe 6. I haven't found the value of HA yet. That's magnification. That's magnification. I haven't found the value of HA yet. You are confusing me. This is magnification. Or you can just let it stay there. That's what most of you did. That may be a better. So magnification, you have this magnification. Is that okay? You have magnification. And magnification is also equal to HI by HO. Also equal to HI by HO. So what is this HI? How to find it? What is magnification? 37.5 divided by minus 25 is equal to HI. You have to find the value of HI and divided by HO. What is the value of HO? That's 4. 4 is the value of HO. So now you can find this HI, that will be 37.5 divided by minus 25 into 4, right? Into 4. What will be the value? That will be the value minus 6. Minus 6. If you are dividing that with 5, what will you be getting? 7.5. 375. Alright, just cut it with 5. What will happen? That will be 5 here, and 37.5. That will be 7 5, right? 7 5 in 37. So that's 35 and 225. That will be 5 again. 75 divided by minus 5 and 7.5. If you are taking it, 7.5 will be the answer. 7.5 into 4. That will be, what is 75 into 4? 75 into 4?
Minus 300.
Yeah, 300. Then 300, take a decimal place, 30. 30 divided by minus 5. 30 by minus 5. That will be minus 6. So HI will be minus 6 centimeter. HI will be minus 6 centimeter. HI will be minus 6 centimeter. Got it now? Okay. Neil, can you sit with one of them? Then you can have that one. Okay. And the next question, there is a third question also. Draw a ray diagram to show the formation of image in this case. Draw a ray diagram. Draw a ray diagram to show the image in this case. What is this case? Look at the case first. What is this case? You are putting the focal length is minus 15 centimeter. You are putting an object in front of it at the 25 centimeter. That is the case. And the image is forming at 37.5. I will just take down the take that readings to here. What is U? U is minus 25 centimeter, right? What is principal focus or focal length? What is the value of focal length? What is the value of focal length? Minus 15 centimeter is the value of focal length. And where did you get B? Where did you get B? Minus 37.5 centimeter. You did get the B. And what was the size of the object? Object size was 4 centimeter. Object size was 4 centimeter. And image size. What was image size? Image size was minus 6 centimeter. You can draw this one with all this label. How will be that? Just draw a straight line first. Draw a straight line first. And put a point there. That point should be center of curvature. That point should be center of curvature. From that center of curvature, draw an arc. You don't have to take the measurements. Just draw a arc that will be your concave mirror. Now, the center of it will be what? The center of it will be principal focus. Principal focus. The distance you have to mark the distance there. What is the distance of principal focus? Or what is the focal length? That is the question. What is the focal length? 15 centimeter. And when you are placing this object, at a 25 centimeter. So this will be what? This will be 30 centimeter. This will be 30 centimeter. 15 and 15. That will be 13 centimeter. 30 centimeter. And you have to place an object there at a 25. So the object will be this. Here. Object will be here. And the object has a size 4 centimeter. Mark that size of object. The object has a size 4 centimeter. And where do you getting the image 37.5? So it will be here. And the image is real and inverted. Where do you get that idea? Image is real and inverted. Where do you get that idea? Because magnification is negative. Magnification is negative and image size is greater. So that will be an image which is real and inverted. Real and inverted. What is the image distance? What is the image distance? That is 37.5 centimeter is the image distance. What is the size of the image? Size of the image is 6 centimeter. Size of the image is 6 centimeter. This is the diagram. This is the labeled diagram. This is the labeled diagram for that. Is that okay? Now look at the next question. Next question. A concave mirror of focal length 10 centimeter. That question. I'm moving to that question. A concave mirror 54A. 54A. A concave mirror of focal length 10 centimeter. Now I am drawing a concave mirror. What is the focal length of it? Its focal length is 10 centimeter. Given as 10 centimeter. What will be the sign of focal length for a concave mirror? For a concave mirror, focal length will be in front of the mirror, right? So it will be minus, and its value is minus 10 centimeter, right? Its value is minus 10 centimeter. Can produce a magnified real as well as virtual image of an object placed in front of it. Draw a diagram to justify this statement. You need magnified real as well as virtual image of an object. Where do you get magnified real? Magnified real image. Where you will get magnified real image when where you have to put the object to get a magnified real image. Where do you need to put an object if you want a magnified real image? Where do you need to put that object? What is this? This is 10 centimeter, right? This is 10 centimeter. This is the pole. And take another 10 centimeter. There will be your center of curvature, right? There will be your center of curvature. And you need a magnified real image. Where do you get a magnified real image? Huh? When the object is beyond C, when the object is beyond C, what will happen? When the object is beyond C, the image will be between C and F. When the object is at C, image will be at C but the same size. When the object is between C and F, the image will be beyond C. It will be magnified, right? It will be magnified and also real. It will be magnified and real. So you need to draw that diagram. How will be that diagram? How will be that diagram? Like this. There is your principal focus. There is your C, and you can measure distances also. If you like to draw it by using measurements, you can draw it like that also. You can take 1 centimeter or 5 centimeter as 1 centimeter. There is something like that. 5 centimeter as 1 centimeter. Have you done this in school? In school, what did you do for this type of questions? This type of questions you didn't do. Okay. You may like take this like this. 5 centimeter is equal to 1 centimeter. Take 5 centimeter is equal to 1 centimeter. So what will be 10 centimeter? 2 centimeters. So 10 centimeter will be 10 centimeter will be 2 centimeter. Like that. So if you want a 10 centimeter, you just take it as 2. You can draw it like that. Is that okay? Then the figure will look like more elegant. It will look like more clarity, with more clarity. Okay. Otherwise, you can just mark the values also. And F is what? F is 10 centimeter in front of the mirror, and C is at 10 centimeter in front of the mirror, right? And then magnified real image. Where you have to place the object? You have to place the object between C and F. What is the light rays that is coming from that object? One light ray is parallel to principal axis that will pass through principal focus like this. Okay, and the next ray will be passing through this. Next ray will be passing through this C, right? Next ray will be passing through this C. My diagram is not correct. That's why I'm not getting the correct values. You will get the correct values, right? Now you will get your image here. You will get your image here. Of course, you can take this one at pole also. That's also okay if your figure is like this. You can also take that also. No problem with it. If you are taking this one, pole, you are drawing to pole. What will happen if you are drawing to pole? With the same angle, you have to draw it back with the same angle. You have to draw it back with the same angle. Okay? If you are drawing it back with the same angle, there you will have an image. There you will have an image of an object. That is, this is height of the object, this is height of the image. This is the labeled ray diagram. Okay? So this is the first question, and the second question. What is the second question in it? An object is placed perpendicular to the principal axis of a convex mirror. Convex mirror. Now you have a convex mirror. You are placing an object perpendicular to the principal axis. Okay. And convex mirror of focal length 10 centimeter. What is the focal length of this convex mirror? 10 centimeter. Where is the focal length of convex mirror? Where does it lay? On behind the mirror, right? You will be behind the mirror. that means it will be a positive value. It will be a positive value. So what is the focal length? It is in the question. What is the focal length? 10 centimeter, right? That's plus 10 centimeter. Plus 10 centimeter. Then after that, what is that? The distance of the object from the pole of the mirror is 10 centimeter. What is that? The distance of the object from the pole of the mirror. An object is placed perpendicular to the principal axis of convex mirror of focal length 10 centimeter. It has a focal length 10 centimeter. The distance of the object from the pole of the mirror is 10 centimeter. That means this is also 10 centimeter, right? This is the pole. This is the pole. So this is also 10 centimeter. That's in the question. The object is placed at 10 centimeter in front of the mirror. You got it? Okay. Then what is the question? Find the position of the image formed. What is the image? Where is the image? That is the question. Where does the image forms is the question. Got it? Is there any confusion? Which is that? Just read the question again. They are saying that focal length is 10 centimeter. That means the focal length of the convex mirror will be behind the mirror. Behind the mirror. So focal length will be 10 centimeter like this. This is the principal focus. And they are also saying that object is placed in front of the mirror at 10 centimeter. Got it? So you just take this object and place it in front of the mirror at 10 centimeter. So you have your value of u. What is u? Object distance. That's minus 10. Object distance is always minus. That's minus 10 centimeter. Right? That's minus 10 centimeter. Now you can find the value of v. That is asked in the question. You just find the v. That is in the question. What is mirror formula? 1 by f is equal to 1 by v plus 1 by u. 1 by 10 is equal to 1 by t. You need to find that. Plus 1 by u. That's minus 10. You just take this 1 by minus 10 to the other side. What will happen? There is 1 by 10 already. If you are taking that, that will be plus 1 by 10. That's 1 by v. What is this? 1 by 10 plus 1 by 10. What is that? 10 plus 10 by 10 into 10, right? That's 1 by v. So 1 by v is equal to 10 plus 10. That's 20 divided by 10 into 10. That's 100. This 0 is gone. 2 by 10. That's 1 by v. So what is v? 10 by 2. That is v. What is the value of v? 5 centimeter is the value of v. So where will you get an object? Sorry, where you will get an image? At 5 centimeter behind the mirror, because it is positive. It is positive. So you have to take a value 5 centimeter from the pole to the right. So that will be 5 centimeter here. You will get image here. You will get image here. Are you getting it, Krida? Is this question correct? Is this answer of this question correct with you? What happened?
I already wrote the diagram.
Just drew the diagram only. Okay. What about you actually? What happened there? Where was that confusion?
I thought we studied reading.
Okay.
I did like that. But when I checked, it was wrong.
Okay. Sierra, is the answer correct? Okay, good. Navin, what about you? You haven't done it, Jonathan, and it's not cool. You have to do that, right? Question first and then answer. Huh? You have to take a photo and send that to me today itself. Can you do that? Neil, no problem. Don't have this. Okay. Okay, that's the. What is the next question? Find the position of the image formed. We have seen that the 55. Question number 55. What is question number 55? Let's see what is the question number 55. Question number 55. Read the question number 55. A security mirror used in a big showroom has a radius of curvature 5 meters. What is security mirror? Convex or concave? Security mirror is convex or concave? Give me Aaron. Aaron, what is security mirror? Concave or convex?
Convex.
Convex. Good. Convex. Security mirror is convex. So we are talking about convex. And big showroom has a radius of curvature 5 meters. What is the radius of curvature of this mirror? That is given as 5 meters. radius of curvature is given as 5 meter. What is the value of this? Or sorry, what is the sign of this? What is the sign of this radius of curvature? Is it plus or negative? Plus or minus? That will be plus because the focus will be here and center of curvature will be here. Right? Then this radius of curvature will be plus 5 meter. Okay. If a customer is standing at a distance of 20 meter from the cash counter, 20 meter, where will be the security mirror? At the cash counter. It will be at the cash counter. And this person is in front of that mirror at 20 centimeter, 25 centimeter. That is the question. 25 centimeter or 20 centimeter. 20 meter, not centimeter. 20 meter. A person is standing in front of the mirror at 20 meter. So U. That's U. Yeah. U is always negative, right? U is always negative. You have to remember that. And find the position, nature, and size of the image formed in this security mirror. Find the position. What do you need to find? Position, nature, and the size of the image formed in this case. Position, nature, and size of the image formed in this case. How can you find position? What do you need to find in order you to get this position? That will be image distance V. That will be V. And this nature. Where do you get this nature of the image? From? Where do you get the idea of nature of the image? Magnification. From magnification. And size of the image? Where do you get the idea of size of the image? From magnification or HI. Or HI. From magnification or HI. Magnification, you will get an idea, or H. Is that okay? Okay. What do we need to find first? The U, the V. Image distance. How can we find image distance? Radius of curvature is 5 meter. So, what will be the focal length? That will be R by 2. That means 5 by 2. What is focal length now? 2.5 meter is the focal length. Okay, that's the focal length. Now you have S and U. You can use mirror formula. 1 by F is equal to 1 by V plus 1 by U. That's mirror formula. And 1 by F. What is 1 by F? 1 by 2.5 is equal to 1 by V plus 1 by U. U is minus 20, isn't it? Take this up. Take this to the other side. 1 by V is equal to 1 by 2.5 plus 1 by 20 will be the value. Cross multiply it. You will get an answer. 20 plus 2.5 divided by 2.5 into 20. Right. What is the value here? 1 by V. Give me the value, guys. What is the value here? 20 plus 2.5 will be 22.5 divided by 2.5 into 20. 2.5 into 2 will be 5. Right? 5. And 5 into 0 will be, sorry, 5 added to the 0, that will be 50. That will be 50. Okay? Okay? Now, 2 into 2.5 will be 5. Right? No, 5 into 0. 5 added to the 0, that will be 50. Okay? So this is 1 by V. Now you have to find V. What is V? V will be 50 divided by 22.5. That will be 50 divided by 22.5. That will be 2 times, right? Right? 22.5 into 2 will be what? $450, right? That will be 450. And 2 into 22.5 will be 45. That will be 45. Right? So 50 minus 45 will be 5 and 50. Again 2.2. Right? So the V will be what? The value of V will be 2.2. The value of V will be 2.2. Are you getting it? Value of V will be 2.2. Is that okay? Yeah? That's 2.2. So you have found the position and what is this nature? Okay, you find nature of the image. Just find this magnification. Just find this magnification. Magnification. Just find magnification. You will get it. What is this magnification? Magnification is minus v by u. What is u? V 2.2 divided by u. What is u? U is what? U is minus 20. Minus 20. U is minus 20. Got it? Minus 20. So what is this 2.2 divided by 20? That will be plus and 22 divided by 20. 22 divided by 200. Right? 22 divided by 200. What is the value? There will be 11 here and 1. 100, right? So 0.11 will be the magnification. Isn't it? 0.11 will be the value of magnification. Got it right? Sierra? Is the value correct? What happened? That's R by. Okay. What about you? Put it correctly. Okay. What about you now? Is it okay? What happened here, Akib? What was the confusion in this? F is equal to 2R. You took it as F is equal to 2R. So this is magnification. And from the magnification, you will get the nature of this image. Magnification is positive. The image will be what? If magnification is positive, image will be what? If magnification is positive, image will be what? Image will be virtual. Image will be virtual. That's one idea. Image will be virtual. Okay? So image will be virtual. If it is virtual, it will be erect. If it is virtual, it will be erect. So virtual and erect image will be that. Okay? So you have the nature. And what is the size of the image? You need to find HI. You need to find HI. That is the size of the image. Magnification is 0.11. Magnification is 0.11. You need to find this HI. So HO divided by HI divided by HO will be the equation. What is the HI? You need to find it. What is HO? HO? Do you have HO? In the question? No, 20 is distance. Distance. Do you have HO from the question? This is 55, right? If a customer is standing at a distance of 20 meters from the cash counter, find the position, nature, and size of the image formed by the security mirror. No. No. The HO is no. HO is not given. Right? HO is not given. So you cannot find HI. Without HO, you cannot find HI. So you cannot find it. You cannot find it. You just have this idea of magnification only, just like you said. You have just idea of magnification only. Then you can say that this magnification is less than 1. You can see that magnification is less than 1. What is magnification is less than 1? What will be the size of image? Image will be lesser size than the object. Lesser size than the object. Got it? Lesser size than the object. Lesser size than the object. That will be the size of image. You can say that about size of image. You will not get a correct size without the value of HO. You will not get it. Okay? So that's the question 55. There is another one also, right? Question number B. 55B. Is it? Can I move to the next page? Jonathan? Can I move? Okay. Then question number B from 55. Question number B from 55. Neha visited a dentist in his clinic. She observed that the dentist was holding an instrument fitted with a mirror. Neha saw an instrument fitted with a mirror with a dentist. State the nature of this mirror. What is the nature of this mirror? That will be what? That will be a concave mirror. That will be a concave mirror with the dentist. And what is the reason for its use in the instrument? Why it is used? It will produce an enlarged image. It can produce an enlarged image. Is the image going to be inverted or erect? If the image formed by this mirror is erect, the dentist may pull out the wrong tooth. Dentist may just look at the mirror and he's seeing that inverted, and he's just picking the tooth which is problematic, which has cavity, and he's just pulling it out. What will happen? That may be the wrong tooth. The concave mirror also can produce magnified virtual image when the object is placed between F and P. So dentist just have to place that teeth near to the mirror, or he has to put that mirror near to the teeth. If the mirror is near to the teeth, it can produce a magnified virtual image. That image will be erect. That image will be erect. No problem at all. There is no problem. Is that okay? Have you written the answer for that? What is the reason for its use? What is the reason why this is used? It can produce enlarged image. It can produce enlarged image. It can produce an enlarged image. An enlarged image. What will be that nature of the image? If it is placed, if the object is between F and P, the image will be enlarged and virtual and erect. Okay? I will add that too. If the object is between F and P, image will be, what will be the nature of the image? Image will be virtual erect. Image will be virtual erect, magnified. Virtual erect, magnified. Virtual erect, magnified image. Virtual erect and magnified image. That's the reason why we are using a concave mirror as the dentist. Okay, so that's it. And look at the question number 56. Look at question number 56. What is the 56A? 56A. To construct a ray diagram, we use two rays which are so chosen that it is easy to know their direction after reflection from the mirror. Use these two rays and draw ray diagram to locate the image of an object placed between pole and focus of a concave mirror. It is this pole and focus. Right? Draw a line. Draw a line first. Then after that, take a point. That point is center of curvature. Take 4 centimeter in the compass. Take 4 centimeter in the compass. Then draw a concave mirror. Draw a concave mirror. Take 2 centimeter from it. Take 2 centimeter from it. That will be principal focus. Take 2 centimeter from it. That will be principal focus. Now you have to place the object. Where is the object? Object should be between principal focus and pole. Just take a 1 centimeter object and place it between focus and P. Draw the first line. What is the first ray diagram? Sorry, what is the first ray? First ray will be parallel to principal axis, and it is getting reflected like this. It is getting reflected like this. What is the second ray? Second ray will be through C. Second ray will be through C, like this. It is going through C like this. As you can see, these two reflected light rays are away from each other. They are going away from each other. That means they will not meet at any point. They will not meet at any point. So you have to extend them. So you have to extend it. You can extend it. Yeah, you can extend it. If you are extending it, this will be the line of extension. If you are extending it, This will be the line of extension. And you are getting an image here, right? What will be the nature of that image? The nature of the image will be like this. The image is like this. So the image is what? Virtual. What is the nature of image? That's virtual. And you can see it is erect. And is it magnified? It is magnified also. So virtual, erect, and magnified. The image is virtual, erect, and magnified. Got it? So that's it. That's the diagram. If you are taking the correct measurements and drawing the diagram will look like more cool. Okay? Do that. Practice it like that. Okay? And question number B. Question number B in it. What is the question number B in it? A concave mirror produces 3 times magnified image on a screen. What is that question? There is a concave mirror and concave mirror produces 3 times magnified image. So magnification will be what? Magnification will be, there is nothing on if it is positive or negative. So you should take it as negative because most of the cases concave mirror will produce a real and inverted image. Only one case concave has a virtual image, that is this. This is a rare case. This is 1 in 6. This is 1 in 6. All the other cases concave mirror produces real and inverted image. So you should take magnification as negative. Magnification as negative. 3 times magnified image on a screen. It is given in the question itself. Image on a screen. What type of image is formed on a screen? Only real image. You will not get a virtual image on the screen. So only real image will be formed on the screen. Nothing. There is no problem. So the magnification will be -3. Okay? That's it. If the object placed 20 centimeter in front of the mirror, the object distance is what? U. That's 20 centimeter. Object distance is always negative. You don't have to think otherwise. Object distance is always negative. Got it, Jonathan? Okay. How far is the screen from the object? What is that question? How far is the screen from the object? What do you need to find here? You need to find B. Where do you get an image? At the image distance. So what is required of you? You need to find the image distance. Right? You need to find the image distance. You need to find B. What is B? That is the question. What is B is the question. How can you do that? It's mirror formula. But before mirror formula, you need to find something with you can work with. Did you get this question? Okay. How can you do that? That's M. That's M. M is what? Minus V by U, right? M is minus V by U. You have a value of M now. You can just take that value of M here. -3 is equal to minus V by U. Is that okay? Is that okay? Okay. What is U then? U is given already. U is given already. This minus and minus will be gone, isn't it? Minus and minus on the same side, it will be gone, right? So 3 will be V by U. What is U? U is minus 20, not 20. Yeah, minus 20, right? U is always minus 20, right? U is always minus 20. If you have to substitute for U, that should be minus. Okay, so minus 20. Then what is the value of V? Just multiply this 3 with minus 20, you will get a value. 3 into minus 20 will be minus 60 centimeter, right? That is the value of V. You should place that screen at 60 centimeter in front of the mirror. You should place that screen at 60 centimeter in front of the mirror. Are you getting it? In front of the mirror, 60 centimeter in front of it. Okay, that's it. That's the second one. That's the second question. Okay. And did we have to do the 57? Question number 57. Question number 57. Let's look at question number 57. Can I move to the next one? Next page? Okay. 57. Look at question number 57. What is the question saying? If the image formed by a mirror for all positions of the object placed in front of it is always diminished. I will write it. I will write it here. Always diminished. The image is always diminished. Erect and virtual. Always diminished. Not only diminished. It is erect and it is not only erect. It is always virtual. Okay. The type of mirror and also draw a ray diagram to justify your answer. Write one such mirrors are put to and why. Write one use such mirrors are put to and why. That's not H. That must be R. That's a question spelling mistake. Okay. So what is this? This is an image which is forming a diminished, virtual, and erect image always. What is this? Must be a convex mirror. So that must be a convex mirror. That's it. And you need to justify your answer. How can you justify your answer? You can justify your answer by just drawing that figure. Just draw a line and take a point there. That point must be center of curvature. And take 4 centimeter in your compass and put this tip of the compass on C and draw the curve. That will be your convex mirror. That will be your convex mirror. And take 2 centimeter from it. That will be your principal focus. Take the measurements and draw. That will be better. Okay. So you are just placing an object in front of the mirror. What will be the first ray? What about the first ray? First ray will be parallel to the principal axis. What will happen to the first ray? It will be like it is reflecting from focus. It will be like it is reflecting from this principal focus. That's the first ray. And now the second ray. You can have the second ray that is directed towards the sea. The second ray is directed towards the sea. Second ray is directed towards the sea. What will happen if the second ray is directed towards sea? It will retrace its path. It will retrace its path. Is it okay? It will retrace its path just like this. Or you can use this pole also. That will also be okay. If you are drawing for pole, you have to take the same angle. You have to take the same angle for reflection. That's the only problem here. If I am drawing that to center of curvature, I don't have to take any angles. That is more easy. Okay. So here you will get an image. What will be the image? What will be the image? Image will be diminished, erect, and virtual. We have justified our answer now. Got it? Image will be diminished, erect, and virtual. We have our answer now. Is that okay? And what is the use of such mirrors? That is the next question. Aaron, what is the use of such mirrors? What are the uses of convex mirrors? Give me some uses of convex mirrors, Aaron.
Used for rear view mirror.
Convex mirrors, yeah, good. It is used as rear view mirror. Rear view mirror. Rear view mirror in vehicles. Rear view mirror in automobiles, in vehicles. Okay, that's one use. Any other use, Sierra? Can you give me another use for convex mirror? Anti-theft mirrors. Not anti, you have to say it like anti. Anti-theft mirrors. Anti-theft mirrors. Anti-theft mirrors in shopping malls and supermarkets like that. Shopping malls and supermarkets like that. And third one, another one. Noah, can you give me a use of convex mirror? Where can you use convex mirror? Top of the ATMs, right? Top of ATMs, they are used on the top of the ATMs. Have you seen that? Haven't you seen that? Top of the ATM, there will be a convex mirror. Anything else? Parking lots. You can use convex mirrors for easy parking lots, for easy parking. These are the uses of convex. On the sharp, on the sharp curves of the road, sharp curves of the road, curves of the road. Huh? An Indian teacher will understand this. I haven't seen this type of mirrors here. Have you seen this type of mirrors in Qatar? I haven't seen. There will be parking lots. In parking lots, there is convex mirrors, but I haven't seen the mirrors in sharp roads here. In India, we can see that. Okay. An Indian teacher will understand this. Most probably, an Indian teacher will be valuing your paper, so this answer will be okay. Okay. That's it. These are the uses of convex mirrors. Got it? Okay.
I got this.
For this exam,
No.
you have done this question. That is good. That is good. And the next one, there is a B question in it, right? There is a B question in it. I'm going to that B question. Can I move to the B question? Just look at the B question then. Look at the B question. Define the radius of curvature of spherical mirrors. What is the radius of curvature of spherical mirror? It is the radius of the sphere. It is the radius of the sphere. Yes, of which the spherical mirror is a. Yes, spherical mirror is a part. Spherical mirror is a part. That's the radius of curvature. So you have radius of curvature. And find the nature and focal length of a spherical mirror whose radius of curvature is 24 centimeter. Radius of curvature is given as plus 24 centimeter. And you are asked to find the focal length of this type of mirror. How can you do that? That is R by 2. R by 2. R by 2 will be 24 by 2. That will be 12 plus 12 centimeter. What type of mirror is this? What type of mirror is this? Yeah, this must be a convex mirror. Why are you not answering this question? This must be a convex mirror because it has a positive focal length. Who has a positive focal length? For a convex lens. For a concave lens, the focal length will be negative. Okay? And for a concave mirror, focal length will be negative. For a convex mirror, focal length will be positive. Okay? That's the 57th question. 57th question. Now 58th question. Did we have to do the 58th question also? Okay. Then look at the 58th question. 58th question. What is the question number 58? Define the following terms in the context of spherical mirrors. First one, pole. What was pole? The center of the reflecting surface was pole. Isn't it? Center of the reflecting surface. Most of you have written it. You may have written it. I'm sure of that. Center of curvature. We just saw what is that. What is center of curvature? Center of the sphere of which the spherical mirror is a part. Principal axis. Imaginary line that is connecting or that is passing through center of curvature and pole. Center of curvature and pole. Center of curvature and pole. That's B. And C. Principal axis. So there is center of curvature as B. Center of curvature as B. And C. For C, it is principal axis. For C, it is principal axis. For D, what is that? Principal focus. What is the principal focus? How you can combine? How you can combine the principal focus? How you can combine them? Combine both the definitions together in a sentence. How can you do that? How will be that? The light rays. Light rays are passing parallel to the principal axis. This is common, right? Parallel to principal axis. Gets reflected. Up to this point, it is common. Gets reflected and passes through passes through a point on the principal axis. Principal axis in the case of or in concave mirror, and yes, and appear to diverge from a point, appear to diverge from a point, on the principal axis, appear to diverge from a point on the principal axis. The point is called the principal focus. In the case of what? In convex mirror. So you can combine the two definitions into one. That is easy. You can combine the two definitions into one. It will be like this. What is that? Light rays passing parallel to the principal axis get reflected and passes through a point on the principal axis in concave mirror and appear to diverge from a point on the principal axis in convex mirror. This point is called principal focus. Is that okay? So that's it. And the second one, there is a second question in it. What is the second question? Draw a ray diagram to show the principal focus of a concave mirror and convex mirror. Very simple question, right? You know that, right? What is that? This is a concave mirror, and the light rays coming parallel to principal axis will be passing through this point. That point will be principal focus of a concave mirror, and it is in the case of convex mirror, it will be like that. Like what? This is the light rays that is coming parallel to principal axis and will pass through. Will appear to diverge from a point. on the principal axis. That point is what? Principal focus of a convex mirror. So that's the question number B. And what is the question number C? Consider the following diagram in which, there's a spelling mistake, in which M is a mirror. Now. The question I will redraw that question here. M is a mirror. And P is an object. You have an object in front of the mirror, that's P. But the principal focus is actually here and C is here. And P is an object and Q is its magnified image formed by the mirror. Q is its magnified image formed by the mirror. There is a magnified image Q which is formed by the mirror. What is the question? State the type of mirror M and one characteristic property of the image Q. What is the nature of the mirror? That is the question. What type of mirror is this? That is the question. What type of mirror is this? This must be a concave mirror. Who can produce an erect image? Who can produce an erect image? Who can produce? Both concave and convex can produce erect image. Okay, that's the answer. Who can produce an erect magnified image? Only concave. Got it? Only concave mirror can produce an erect magnified image. So this must be a concave mirror. That's first one. This must be a concave mirror. That's it. Then this is the first answer. And write some properties of the image formed by this concave mirror. What may be the image? This image Q. What is this Q? Q is what? Q is enlarged. Anything else? It is virtual. It is erect. That's why we can say it is virtual. It is erect. So the image must be virtual. So it is virtual and erect. Then virtual and erect. Then anything else? That's enlarged. Magnified means enlarged. Okay, and it is behind the mirror. Formed behind the mirror. It is formed behind the mirror. Formed behind the mirror. Formed behind the mirror. Got it? Formed behind the mirror. Do you have any other question that is left to discuss? Do you have to discuss? Do we have to discuss the 59 question? Huh? 59 question was given by me as an assignment, or up to 58? Up to 58. Up to 58. Should I look at my mobile phone? Okay. Up to 58 or 59? Home assignment 53 to 59. 53 to 59. So you need to do the 59 also. Need to do the 59 also. It is decided to obtain an erect image of an object using concave mirror of focal length 12 centimeter. I'll move to the next page. What is that question 59? What is that question 59? It is decided to obtain an erect image of an object, right? Erect image of an object. I am just stating that again. And using concave mirror of focal length 12 centimeter. What you are using? You are using a concave mirror, and it is having a focal length of 12 centimeter. What is the focal length of concave mirror? Positive or negative? Positive or negative? That will be negative, right? Like will be in front of the mirror. So minus 12 centimeter will be the answer. Okay. And first question, what should be the range of distance of an object placed in front of the mirror? What should be the range of distance of an object placed in front of the mirror? What is the range of distance? First question. Range of distance. What is that? Range of distance. What are they asking for us to find? Range of distance of an object placed in front of a mirror. What is that? Range of a distance. Range of distance of object placed in front of a mirror. Range of distance. Where you can place the object. That is the question. Range of object means? Range of object means? Range of object distance means? Where is the object distance ranging from? It is ranging from T to infinity. You can place the object anywhere in between them. Anywhere in between these 2 points, infinity and P, you can place the object anywhere. Okay. If they are asking for the range of image, that will be what? What will be the range of image if that is asked like that? What will be the range of image for a concave mirror? There will be an image at infinity. So the range of image will be from infinity to what point? To infinity from F. Not just F. It can produce a virtual image also. Virtual image will be out of the F. Virtual image formed by the concave mirror will be behind it. It will be behind it, right? It will be behind it. It is magnified image. So it will be minus infinity to behind the mirror. That is asking like that. Infinity to behind the mirror. Infinity to behind the mirror. Range of image. So that's the first question. And the second question, will the image be smaller or larger than the object? Will the image be smaller or larger than the object? Where you are taking the object, it is decided to obtain an erect image of an object. We have missed a point there. There is a point in the question. There is a data in the question. They are asking for erect image. They are asking for erect image using concave mirror of focal length 12 centimeter. That's why they are asking for the range of object. What will be the range of object? Where do you need to keep the object? This is not correct. If this data is given, where do you need to place this object? If you want to get an erect image from T to F, right? F to P. F to P. So you have to place this object Range of object will be from where to where? Range of object from 12 centimeter to pole, right? 12 centimeter to pole. 12 centimeter front of the mirror to pole. From 12 centimeter in front of the mirror to pole. 12 centimeter in front of the mirror. If the object is placed at 12 centimeter, what will happen? The image will be formed at infinity. So that's not correct. You should not place this object at 12 centimeter. You cannot place that object at 12 centimeter. It will be less than 12. Right? It will be less than 12. So that is, there must be a correction for it. Range of object from less than 12 centimeter in front of the mirror. In front of the mirror. Range of object is from less than 12 centimeter is less than 12 centimeter in front of the mirror. Less than 12 centimeter. Then only you will get an erect image. If the object is placed at 12 centimeter, what will be the image? Image will be forming at infinity. Right? They are asking for the erect image. So that if you want an erect image, this is F, that's 12 centimeter. If you want an erect image, the object should be between this. Object should be between this. Or you can say it like that, between 12 centimeter and 4. Now that may be okay. Between 12 centimeter and 4. Between 12 centimeter and 4. Is that okay? So what is the next one? What is the next one? B, question B. What is question B? Will the image be smaller or larger than the object? Will the image be smaller or larger than the object? If you are using a concave mirror, it will be larger. It will be larger than the object. It will be larger than the object. And draw a ray diagram to show the formation of the image. You have done this already on many times. Okay? So that's it. Ray diagram also. I'm not drawing that. You have to draw this ray diagram also. What is the C? Question number C. Where will the image of this object be if it is placed 24 centimeter in front of the mirror? 24 centimeter in front of the mirror means U is equal to minus 24 centimeter. Isn't it? Okay. And draw ray diagram for this situation also to justify your answer. Where will the image of this object? Where is the image? That is the question. You can use mirror formula. What will be the mirror formula? What is mirror formula? 1 by F is equal to 1 by V plus 1 by U. 1 by, what is F? Minus 12 is equal to 1 by V. What is V? You have to find it plus 1 by U. What is U? Minus 24. That is 1 by V is equal to, there is 1 by minus 12 here. You can take that to the other side of the equation. That will be plus 1 by 24. 1 by 24. Then 1 by V will be 24 minus 12. Right? Cross multiplying it. Minus 12 into 24. What is that? What is that? 24 minus 12 will be 12. 24 minus 12 will be 12. 24 into 12 will be what? Just write it like that. 24 into 12. 12 into 24. You can now take this 12 out. You can take this 12 out. That means the value is 1 by minus 24. That is 1 by V. So what is this V? V will be minus 24 from V. V will be minus 24. Got it? V will be minus 24 centimeter. Is that okay? So what is that? What is this minus 24 centimeter actually is? Object distance and image distance is same. What is that scenario? This is actually C of this mirror. This is actually center of curvature of this mirror. That's why you are getting 24 centimeter as object distance and 24 centimeter as image distance. That is, this image is forming at C. What will be the size of this image? Same size. Image size will be same. What will be the nature of this image? Real and inverted. It will be real and inverted. We can see that from here. The nature of the image will be real and inverted. Got it? That's it. So that's our question. That's our end of the discussion of the question. Are you okay? Okay. Should you need a break? Hmm? Do you need a small break? Or we can continue. You don't have any session after this.
I just need to do
Just go and have some water. If you want to use the washrooms, just do that also. Be back here as soon as possible. Right? Don't take too much time. Just 5 minutes. Okay? We have changed the book. I'll inform you. Right? Now. You may have to change the rule. I will inform you this one. Okay? So class will be class number 8 on the first floor. No? After the break. Is that okay? I will come to this. You have a settle there. I will come there. Okay. Aaron, give me a minute. I will resume in a bit. Okay.